So here we're going to start on 465, actually, with what is known as the linear search of an array. Now, to set this up, what I'll suggest here is the arrays that we have been using are microscopically small, right? So we have had arrays of size 20, of size 50, and those are itty bitty 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 bitty. So some of the concern that we are just like dumping here into 8.1 isn't necessarily going to make satisfying sense, considering 25 or 50 for the size of your array. But what we're saying is that a linear search of an array. I keep wanting to say sort. I have them backwards because my brain reverses things for you, which is terminal and incorrect. But the linear search of an array suggests the following. And it's here, we can see the code for it on 465. So this is not one of those where I'm suggesting to you that there's more than one way to do this. The science, the code on how to do a linear search is literally right here for you. And what we're really doing is explaining, number one, how it works, number two, why it's inefficient. So let's first go into how it works. So what we'll know is that we have an array of a given size, and because we know that arrays know their own size, the most efficient way for us to go about doing this, and again, you can see it here, is page 465. The most efficient way for us to do this is simply to start at element 0 and work our way up using a counter. And we check the element of the array versus the desired thing that we are searching for. So this particular piece of code, I have too many mice in front of me. Here we go. This particular piece of code right here, we're using a while loop. You could use a for loop. They work just as well. Because the iteration is, again, actually in the setup for your for loop. So whichever you choose to do. So what we're doing is we're using, in this case, this while loop, which is on line 43 rather. And we're saying if index is less than size, so as long as we can loop as many times as we have an array, right? Because remember, with an array, C++ will allow you to keep trying to traverse past the outer bound of that array. So that's why we have the if, or the index is less than size rather in our while there, is because we want to remain inside of the bounds of our array. And found, we're saying there's a flag there where we will mark the flag as found, true, if we have made a match. So essentially what's happening here on lines 47 and 48, or 45 through 48, is we are taking the value that is stored in the element of the array, and we are comparing it to whatever our search string is. And if they're the same, we mark our flag as true, and boom, we know that we have discovered, we have searched and found whatever our search string is. If they are not the same, we'll keep looping. We'll go to the next element of the array, and we'll try it again. And if it's true, we'll stop. If it's not, we'll keep going. It's false, we'll keep going. We'll go to the next element of the array. We're going to see if their values are equal. If so, we have located what we are looking for. So you can see, I think, that this is pretty inefficient. Because if we have, a 50 element array, we'll be done with this in pretty short order, right? If we have a 500,000 element array, we might not be done with this in short order, depending on the system we're running and everything like that. If we have a 500 million element array, not that hard to do when we're working with big data sets. That is inefficient as hell. That is going to take a long, long time to get through. So the linear search of an array is brute force, and it is guaranteed to work eventually. It will locate a searched for item. Yes, absolutely. But it is not necessarily the most efficient way to do that. For the most efficient way to do that, we have to go to our next video, which is the binary search of an array.